Hello. Okay, it's exactly 2 o'clock on the last day of Build, so I can't really say welcome to Build, but I'll say thanks for coming to Build. I know a bunch of you are watching this on video. Others are probably in a cab to the airport right now, but for those of you who did come, who did make the time, I promise you I'm going to try and make it worth your while. Okay, so my name is Arun Singh. I work on the Windows developer platform team. We're the people who put together the APIs that you use to write your apps, and thank you for all the apps. My Twitter handle's up there, my blog's up there, and all of the code that you'll see in this session today, all of the demo code, is up in that GitHub repository up there. I can't take credit for most of that code, because most of that code was written by Sandeep, who's here. He wrote most of that code, and I keep repeating that because all of the bugs in that code, those are his. If the UI ain't pretty, his fault. But you know, the APIs are there. And we're not the UI team, just to emphasize before we get to the UI. Please give me feedback. We're very competitive in our team. If you went to Thomas's session, he asked for feedback. I'm going to ask for feedback too, because I want to win. And yeah, that's it. Andrew Klinick talked about a bunch of application model features that we're bringing to this conference on his talk on the first day. This is where you learn about app services. Hopefully, you've been able to attend some of the other sessions and have more of an idea of the app model improvements we're bringing in with Windows 10. And the clicker just stopped working. OK, it works. It works. Maybe more than one click. So as you walked into this session, you might have seen that we have a new byline this year. I did the same app-to-app communication session last year as well, for those of you who were here. And the byline this year is the web of apps. And Andrew talked about this briefly, so did Kevin in his keynote. And we're inspired by the web. It is the biggest platform known to man. There's hundreds of millions of websites, possibly 1 billion plus, and they work together great. And that works for apps too. Today, an app on pretty much any device can reach out to a website hundreds, if not thousands of miles away, get some data from it, display it to you, make transactions happen, send a user to the website. It can do all of these wonderful things. But when an app tries to talk to another app on the same device, well, we don't see that often enough. So our goal is to effectively help you build a web of apps on your users' devices, where apps talk to each other as often as they talk to websites. I mean, they shouldn't stop talking to websites, because that's great, but they should also talk to each other. So that's the rationale behind that intriguing byline. So the first thing you want to do when you want to build this web of apps is you want to be able to link to other apps on the same device. Now, we've got an API called Launch URI Async. Does what it says on the tin, exactly what it sounds like. You can launch a URI. But not only can you launch web-style HTTP URIs, but you can also launch URIs that are based on custom schemes. So here's an example. Say your user starts out in app A. They click a button somewhere, do some interaction, and app A uses the Launch URI Async API to launch this URI, which isn't an HTTP URI. It's myapp : O equals yes. I just read out something on my slide. But anyway. OK, so let's assume app B, which is also on the same device, signed up for that custom scheme, the custom scheme called myapp. What's going to happen here is that app B gets launched, it gets given that URI, and all is well with the world. And you just managed to deep link into that app. It's pretty straightforward, and all of this stuff works today. This is available on Windows, Windows Phone, Xbox, pretty much all our platforms. It works on Android and iOS too. So why am I talking about custom schemes in the context of Web of Apps? Well, One nice thing about custom schemes is that they've been around a very long time, pretty much since 1996. In fact, they were introduced right here in the Moscone Center by the Internet Explorer team. So never say that Internet Explorer didn't give you anything. They gave you custom schemes. And they're so popular that they've made their way across to Android and iOS and most flavors of Unix as well. So that's awesome. The reason that's awesome is that you can do a custom scheme and have it light up on pretty much any platform out there in the world. The third interesting thing that's happened over the last year or so is that a lot of our partners in the tech industry, a lot of the big tech guys, your Facebook, your Google, your Microsoft, have become very interested in the idea of this web of apps. And there's these initiatives. The first one is Facebook's App Links, not the first initiative, but in no particular order. Facebook has the initiative called App Links. Bing also has an initiative called, confusingly enough, App Link. Google has app indexing. And the basic idea with all of these initiatives is to take an HTTP URI, a web URI, and transform it into a custom scheme that somebody can use to launch an app on a device. So there's industry momentum behind this idea. You're going to see more and more people talk about it. So that's stuff that works today, and it's great. But we're talking about Windows 10, and we've been working over the past year making sure that Windows is ready as a platform for all of these initiatives. When you want to build a web of apps, we want Windows to be first class. So what have we done? Well, the first problem we went after was what I'm calling the evil twin problem. And I'm coining that term. I haven't heard it before, so give me credit if you repeat it. Anyway, the evil twin problem goes like so. Your user starts out in app A, they click a button, do something. App A tries to launch app B again, uses a myapp : a custom URI, a custom scheme URI. Except in this case, you've got app B installed on the device, but you've also got its evil twin on the device. Now, the evil twin happens to sign up for the same scheme. Now, it's not always evil. Maybe you chose a scheme like myapp : like I did. And it's so common, somebody else watched this session and chose the same scheme, and you ended up in this place. But what happens when this happens? The user gets to see a picker. And now, based on the little information that they have about what your apps are and what they can do, they need to make a choice, and they need to make the right choice to make the information flow correctly and to make the scenario work. But that's not great, because now there's a big potential that you might end up breaking your scenario. So what did we do about this problem? Let's look at a quick demo to find out. Okay, switching over to my laptop. And I've got a test phone up here. You see it? OK, it's up there. And I'm just using a Windows Phone device. And for the next demo, I'll be using a desktop device, just because we can get some variety in here. And what I've got is I've got an app called Build 2014 Photoblog. That's this app here. And we brought this app for a demo last year. And all it does is it lets you post pictures from, well, I guess Build 2015. Forgot to update the title. But it lets you post pictures from Build 2015 to a Tumblr blog that we set up last year. And I'm not going to go into the details of this app other than say that I launch URI enabled it. I signed this app up for a custom scheme. And the internal name of this app is TumbleMe, because we're talking to Tumblr. We've also got another app called Fake TumbleMe, which will play the role of evil twin. And it signs up for the same custom scheme, as you'd expect. And then we've got a third app called TumbleMe Launcher. And all it does is it tries to launch TumbleMe. It tries to launch the Build 2014 Photoblog app. But look what happens. You get a picker. And depending upon what choice the user makes, they might end up in the right place, or they might not end up in the right place. OK, so let's switch back and figure out how we might fix this problem. So here's the code for TumbleMe Launcher. It has only one button on screen. as we just saw. And that button literally it literally launches a URI scheme. Now, I've been a little bit more smart with this app, and I've used a reverse domain naming convention for my custom scheme, which is a nice thing to do, because that way, because I own aruntalkstech.com, I can make a reasonable assumption that another non-malicious app won't try to take over my custom scheme. So I've done that. But what if the other app is, in fact, malicious? What if it wants to steal my user? So what we did was, we now allow you, when launching another app using launch URI async, to specify an option. And the option's called target application package family name. That's it right there. We love long property names, as you'll see. Somebody's got to sell IntelliSense, guys. Oh my God, Visual Studio team is going to kill me. But OK, so I love IntelliSense. I love Visual Studio. I have it on video. OK, so so where do we get this package family name from? I'm going to come back to that question in a little bit. But here's this long-ish value, which all it does is basically it identifies the right app. It says, I want to launch this scheme, yes, but I want to make sure that the app that handles this scheme is this one. And this is my TumbleMe app. This is the right app. And we're just going to plug those options in. And that's it. That's all the code I need. OK, let's deploy TumbleMe Launcher down to my device. And incidentally, this is a real device. This isn't an emulator, because I like to live with risk. Deploy, please work. OK, it did work. Nice. I shouldn't act so surprised. All right. So you remember what happened the last time we launched TumbleMe Launcher? We were looking at this button, and we saw a picker. Well, this time, I'm going to press the button again, and that's it. That's all it took. So it's a small addition, yes, but it enables you to make your users go down a road that you want them to go down. And I'm sorry I'm spending more time on this side of the stage, incidentally, because they've got this giant table over here, and I don't like hiding behind a table. So that's how you launch a specific app. And there's a nice animation showing what we just did. And that's how you get a package family name. Now, the package family name isn't some secret piece of information that you're supposed to keep to yourself. All it is a unique identifier for your app in the Windows Store. You don't necessarily have to put your app in the Windows Store to get a package family name. You literally call this API, Windows Application Model Package Current ID Family Name. Remember what I said about long APIs? Well, you call this API, and you get a family name back, one of those strings that I just showed you. And you hand it to whoever needs to launch your app, and they can do what I just did. It's that straightforward. And the package family name is something that is generated by Visual Studio when you go File, New App. You can actually go into the store and reserve a package identity name and use that as well, and then you're sure that nobody else is going to take it. Also, part of the package family name is a hash of the certificate that your app is signed with. So unless you lose your name reservation and your certificate, in which case you've been very, very careless, you're not going to lose your package family name. So it's pretty secure. We made some other improvements. Sometimes you want to launch another app, and you want to send it a file, because you don't want to take a gigantic file and serialize it to a string. OK, reasonable ask. You can do that now. There's a new API called Shared Storage Access Manager. It has a method called add file, gives you back a token. The token is a GUID, and the GUID is a string that you can stick on anything and send it to another app. The other app can take that string, put it into redeem token for file, and get a storage file back. It's that simple. And it doesn't have to be used with launch URI. Literally, you can literally use any mechanism to get the string across to the other app. The other set of things we added was the ability to query for support. You have a scenario that involves multiple apps, maybe your app and your friend's app, and you want to figure out whether your friend's app is installed on the device. Well, query URI support async is the answer. It lets you do that. Another improvement we made was the ability to enable extension-like scenarios, wherein you say, hey, I'm this popular app. You want to show up inside of my app, you go implement my app-extension custom scheme in your app, and at runtime, I'm going to ask the device, are there any apps that support my app-extension? We're going to give you a list back, and the API is called find URI scheme handlers async. So I'm not going to go into demos for these because they're kind of self-explanatory, but if you would like sample code, I'll be putting up more sample code on that GitHub repo that I talked about before, and I'll be blogging about it as well. The last improvement that we made to deep linking is called launching for results. So now, there are times when you've got these scenarios where you do want to send your user to another app, but you want the user to do something in there and come back. A good example is you're a game, and you want the user to tell their friends about this great game they just played, okay? Except the user's friends live in another social networking app. Substitute your favorite social networking app here, and you launch that app for results, have the user select their friends, and have that app send the list of friends back to you as a result. So you're launching the other app, except with the expectation that the other app is going to send the user back and possibly some results back. So how does that work? Well, it's pretty straightforward. Again, we start out in app A, and the only thing different in this piece of code is that third line there. Instead of calling launch URI async, we're calling launch URI for results async. Incidentally, this is how our names get longer and longer. But okay, launch URI for results. You send in a URI, the same kind of options because you want to identify who you're launching, and that's it. And that is an awaitable method for you C# fans. I am one as well. That's an awaitable method which brings back a result when the method completes. And it's also, you can also use it with JavaScript and C++ promises for those of you of a different persuasion, and that works too. So the results are actually a structure called a value set. So this the code at the bottom is what app B would do to return the results. So it sets up a value set, and value set isn't new. It's a type we introduced last year with Windows Phone 8.1, and it's a simple property bag / dictionary. It can carry integers, strings, floating point numbers, byte buffers, byte arrays, what have you. So think of value set as RJSON, if you will. You can pretty much serialize anything down to a value set. Okay, let's look at a demo. Switching back to my laptop, and this time we're going to try and do this with a desktop app. So what I've got is an app called Contoso Shop. Let's just see Contoso Shop running. And for those of you who haven't heard, Contoso Shop is this great e-commerce site that you will not find online. And it's great. I buy everything I want at Contoso Shop. It sells 4 things, and those are the 4 things I need, incidentally. And so let's go ahead and buy one of these laptops. They didn't give speakers laptops. They gave you all those awesome laptops. They didn't give any to us. So I need to buy a laptop. And I click on the buy button, and nothing happens. Of course, nothing happens because there's no code in there. OK, so let's take a look at the code. What we want to do here is we want to use this other app here called Woodgrove Bank, which is also a very famous bank, to try and authorize the payment. So Contoso Shop does not understand how to authorize payments. So it's going to try and launch Woodgrove Bank to authorize the payment, because presumably the user has an account in Woodgrove Bank. And if they approve of the payment, because Woodgrove Bank will be launched for results, it'll say, yeah, the user bought, and everything's good with the world. Or it'll say the user didn't buy, sorry, try again. And so this is obviously a contrived scenario. Please don't treat this as a starting point for an e-commerce scenario, because Woodgrove Bank won't sue me, but Bank of America might. So let's go into Contoso Shop and try calling Woodgrove Bank for results. So that's the main page we were looking at. Let's get in there, and let's get rid of this. And so, buy monitor goes here, buy laptop goes here, buy phone goes here, and so on and so forth. This code is obviously not production ready because there's no MVVM or new view models in here, but I wanted to keep it simple so that we could focus on the APIs. And I'm going to be lazy, and I'm going to use code snippets instead of typing code. Because I didn't tell you this, but I'm a program manager. I don't write that much code. I wrote code for 11 years, but now I program. I now tell other people to write code, and then pretend I do. OK, so we launched Woodgrove-Pay. We set the target application family name. We've already seen this. What we're also doing is we're taking the product information, the product that the user selected. We're taking the product name. We're taking the amount that the user needs to authorize, and we're putting that in a value set. Not only can you get a value set back when you do a launch URI, you can also send one in, right? And we could have stuck all this information on the URI if we wanted to, but this is just, I want to show off this feature. Also, we want to send a picture of what the user is trying to buy into Woodgrove Bank as well. So we take that picture, we turn it into a token, and we stick the token into the value set. OK. Finally, we launch Woodgrove Bank app for results. So there it is. And 3 pieces, the URI, the options contain the target package family name, and that's the input data. And then we await the result. And when the result comes back, we inspect the result, which the result that's coming back is from Woodgrove Bank. We inspect it to see if the user actually said status success. And this is how you know this is a naive, contrived scenario, because there'd be a lot more stuff in there in real life. And then we go to order place page. OK? Let's try it. And it's building. There we go. OK, so this time I'm going to buy my laptop. So you see Woodgrove Bank came up. That's a separate app. That's not part of the same app. And so because it was launched for results, it came up in a modal fashion. I cannot interact with Woodgrove Bank, Contoso Shop until I'm done interacting with Woodgrove Bank, because Contoso Shop is waiting for results. So, and here's the little accept button. Now, if we switch over to the Woodgrove Bank app, and we look at the payment page, because that's where we are at the moment, and let's go in here and look at what the accept button actually does. There's a click handler for the accept button. And what it does is it actually sets a value set, sets up a value set, puts a success in it, and calls report completed. OK, switch back to Contoso Shop, say yes, and that's it. That is the order placed page. OK, so how does Woodgrove Bank actually sign up to be launched for results? Well, apps have been able to sign up to be launched for results through their Apex, to be launched with a custom scheme through their Apex manifest in the past. But to be launched for results, you have to do something slightly different. So here's the Apex manifest for the Woodgrove Bank app. And in there, we've got this thing. But here's an interesting new thing called return result. And what Woodgrove Bank is saying here is, you need to always launch me for results. So if we try to launch Woodgrove using that custom scheme, this custom scheme, Woodgrove-Pay, and we use launch URI async, it wouldn't work, because Woodgrove Bank has said, I can only be launched for results. Now, it could also say optional in here, and that would mean that Woodgrove Bank understands what to do if it's launched for results, but it can also do something useful when it's launched straight up using launch URI async. OK. Back to some of the slides. So that's launching for results. It's not that different from launching an app straight up. The provider, the app you're launching, has to do a little bit of extra work. They have to say they want to be launched for results, and then when they are launched, they have to detect whether they were launched for results, and then they have to send results back. But again, as you saw, it's not that much more code. The second big piece of the web of apps puzzle is what we're calling app services. Now, I know Azure also has a thing they're calling app services, and I hate that. No, I don't actually. But it maps great, because their app services actually live in the cloud. And the app services I'm going to talk about here live on the device. There's a lot of web concepts here, but there's no actual web server involved. And that's important to understand, because we didn't want to put a whole web server on the device you're carrying around in your pocket, for obvious reasons. And the idea is apps provide services to other apps. You need a little piece of data from another app, you call its app service and ask the app. You need to send something to the other app, you call its app service and ask send it to the other app. And you could do all that stuff with Launch URI and Launch URI for results as well, but sometimes you want to do that stuff without actually bringing up the other app. And here's a great analog. On the web, when you go to a new website that somebody came up with, some new hot new startup, and they're like, oh, you need to sign up. And you're like, another giant form to fill out, except then you see a button that says, sign in with Microsoft, sign in with Google, sign in with Facebook. And you're like, aha, that's what I'm going to do, because I'm going to save myself some work. So what's going on there? All the website is doing is that it's using a web service, in this case, probably an OAuth web service that's provided by Google or Facebook or Microsoft, and leveraging that to provide you functionality that it doesn't necessarily have. And that's what app services let your apps do on device. So how does an app service work? Well, if you've written code for the modern Windows platform before, you probably know the way to execute code without showing UI falls under the general umbrella of what we call background tasks. So an app with an app service is nothing but a package with a bunch of background tasks, right? And all you do is you say, this background task over here is actually an app service. You put some stuff in the manifest and you say, this one over here is an app service. The name of that app service is foo. And the other guy says, OK, I need to access foo. And that's how they get talking. So how does it work? Client app A comes along. It needs to talk to an app service that lives in the package on the right. It creates a new app service connection. It gives us an app service name. This is the name that the owner of the app service defined in their manifest. It gives us a package family name, because we need to know which app the app service lives in. And it opens a connection. And if everything went well, we spin up a background task in the app that provides the app service. At this point, this becomes a two-way connection. The client app can talk to the app service, and the app service can talk back to the client app. It's a full two-way channel. So how do you send messages? Well, our old friend, value set. You put together a value set, you stuff some data into it, and you say, send message async. And send message async is a simple request response API. You send in a request, and the web service responds, the app service responds with, yay, I got that message. And if the app service wants to send you a message back, it can do that as well. When you're done with the app service as the client app, you just dispose the app service connection. Now, I'm a C# lover, so I'll dispose. But those of you who are using C++ will want to close. So it works slightly differently, but not that different. OK, so that's great. What if another app comes along at the same time and asks for the same app service? What happens then? Well, we do exactly what the web does. We spin up another instance of the same background task, and that serves client app B, so that if client app A chooses to tear down its app service connection, there is no side effect on client app B. So where do we use app services? Because all of these features aren't just for you guys. We've been a little bit selfish. We've been using these features the whole time. So the People app, for those of you who've used Windows phones, is kind of our address book app, but it's so much more than that. It can also pull in news feeds for your contacts, provided you have Facebook or Twitter or wherever your contacts live installed. And the way that works is that the People app invokes an app service that Twitter or Facebook provide and pulls in that data. And it can also pull in other stuff like contacts and tile updates and all of that stuff. In the past, your apps have not been able to do what the People app can do. Well, they can now. The other interesting scenario that we're exploring right now is about sharing cache data. So here's a scenario we dreamed up. Say you're writing a Windows Phone app or a Windows app, and you're using a map control. Now, that map control is probably going up to the Bing Maps web service and pulling down tiles for the local area. Except it doesn't really need to do that. Those tiles probably already live on the device because the user has used the Maps app on the device at least once. So there's no reason to actually go up to the cloud for this. So we're envisioning a map control that actually talks to an app service that lives inside the Bing Maps app and just pulls that data in. Now, this isn't part of Windows 10 yet, but we're looking at it. The other interesting scenario is hardware access, and the band team is actually working on this right now. We've been working with them, and they're looking at it, and hopefully at some point in the future, they can do an SDK that actually uses app services. And the idea is simple. You're an app that can talk to a hardware device like this one. Ooh, my heart rate is way up, guys. You are making me nervous. Okay, so small digression. But the band app can talk to the band. It has historical data on what your band's been doing, what your heart rate's been over all this time. And other apps, client apps, instead of talking to the band directly, in which case all they get is the data right now, they can actually talk to an app service that a band app provides. And the band app can effectively arbitrate access to that data. If the band isn't actually around at that moment, maybe it can provide historical data. Maybe it can also provide observations based on that data that the band obviously can't provide because it doesn't have a whole lot of processing power. The last scenario I want to talk about is really, really close to my heart, guys, because I spent 4 years as an enterprise consultant. Some of that doing SharePoint, but a lot of that doing mobile app development as well. And if you've been in an enterprise, you'll realize that most employees don't just get all their work done through the day using one app. They're likely using a suite of apps, some of it which are custom apps, some of which are coming from other third parties. And those apps need to talk to each other to get stuff done. App services and the deep linking APIs are a great way for that to work. So the scenario here is relatively straightforward, possibly a store where you've got a checkout app that knows how to talk to the payment gateway, an inventory app that now knows how to talk to an inventory service, a product scanning app that knows how to talk Bluetooth or NFC or RFID so it can scan products, and all of them can work together to do all sorts of scenarios that aren't possible with the way stuff is set up today. And the clicker, it works. Okay, so enough talk. Let's look at some code. So I'm going to bring you guys back to the same shopping demo that we were looking at just now. And so we've gone and bought the thing, the laptop. I've gone and bought the laptop on Contoso Shop. So what happens next? Well, the laptop probably gets handed to some sort of shipper, like FedEx or UPS or whoever, and it gets shipped to me. And I track it as it makes its way through however it is that shipping services work, which I've never been able to understand, but that's okay. What Contoso Shop does is that it provides the ability to see where your package is right within the Contoso Shop app, rather than having to go to the ShipTrack app or the ShipTrack website. ShipTrack is our shipper, by the way. Fabricam ShipTrack, to be exact. And the way that works is that Fabricam has an app that presumably the user has installed on their device, and that app provides an app service which lets another app put in a tracking number and get the status of a shipping request out. Now, obviously, the user can also go directly into the Fabricam app and do that, but again, somewhat contrived scenario, but it shows off very nicely what I'm trying to say. Okay, so if we start up Contoso Shop again, we started up Fabricam ShipTrack, which does nothing, only provides an app service. It has an order history page, and that's where you go to see where your order is in the shipment process, right? And it doesn't do much at the moment because we haven't added any code. So here's the order history page. Here's where that button takes us. And in the order history page is onNavigated_to method. I retrieve the order information, which I've got serialized to a file, including the tracking number. And once I have the tracking number, I get the shipping status from the Fabricam ShipTrack app, which provides that app service that I need to use. So again, code snippets. So here's how I open a connection. I create a new app service connection. We kind of saw this code already. I give it an app service name. This is the name of the app service that lives inside the Fabricam ShipTrack app. I give it a package family name, which is the package family name for the Fabricam ShipTrack app. And don't worry about that package family name, because I haven't submitted Fabricam ShipTrack to the store. And that's just a generated name that Visual Studio made up for me. And then if everything went well, I send Fabricam ShipTrack service my tracking number. I put it in a value set. I send it as a message. I get a response back. And then I take the response and just stick it on the screen. That's all I do. So before we actually run this code, we need to make sure that Fabricam ShipTrack is actually deployed. OK, it's on there. Did that just start? No. OK, there we go. And let's put a little breakpoint in here, just so we can run through the whole process. OK, so I bought the laptop. Let's go into the order history. We go in here, and we create the app service connection. We open it. Everything went well because the status is success. Send in the tracking number. Response comes back. That's a fast app service. And the status is, processing order. It hasn't shipped yet. OK, so that's it. That's how you call an app service. But how do you build an app service? Well, let's go take a look at the code for the Fabricam ShipTrack app service. So here's the ShipTrack service. It lives in a separate WinRT component that I put together. And all you need to do to build a background task, because remember I said app services are background tasks, the first thing you need to do to build a background task is implement the iBackground task interface. That's how we know it's a background task, because it's at iBackground task. And it only comes with one method, really, the method called run. And this is the method we call when we bring up the background task. So what does this background task do? It takes a deferral. Now, why is it doing that? The reason it's doing that is because unlike other background tasks, which start up, do something, and then go away, in this case, we want this background task, the app service, to keep running so that it can service requests from the client. So we're saying to the platform, hey, don't just kill me once I'm done with the run method. You want to keep me around because I have requests to handle. OK. And the other thing we do is that we take out the trigger details. Now, trigger details come in as part of an argument to the run method. And this is what tells the background task, this is what gives the background task details on what it's supposed to do. So in this case, they're app service trigger details, because it was launched as an app service. And it has a request received handler. And that's where the requests from the client come in. So when the client says send message, this method here gets run. And it gets the message. And we take out the tracking number. We fetch the tracking status, and I won't go into that. It might be a web service. It might be some other mechanism. And we put together a result, and we say send response. And that's it. That's the whole app service. It's 67 lines of code. But there's one more thing that the app service author needs to do before somebody else can call their app service. which is that in their app, this is the Fabricam ShipTrack app, and as you can see, it has a reference to the ShipTrack service we just looked into. They have to tell the world that my app provides an app service. So they do that in their manifest. So here's the Apex manifest for Fabricam ShipTrack. And this is all boilerplate stuff, but down here is the interesting stuff. We're saying this app provides an app service. The code for that app service lives in this background task called ShipTrack service or tracking service. And the name of that app service is tracking service endpoint. Now, if we quickly circle back to Contoso Shop and look at the code where we called the app service, we'll see that's the same name we used here. And that's it. That's an app service provider and an app service consumer. So before we move away from app services, there's one more thing I'd like to talk about, debugging an app service. Because it's going to be hard, because Visual Studio can't launch your app service with the debugger connected. Your app service will be launched by another app, and you want to debug the app service, not the other app. So this is how you do it. You go right-click the project, in my case, Fabricam ShipTrack, and you tell the debugger, do not launch this app, but lie in wait for when the app launches, and then pounce on it and attach the debugger. And it'll do that for you, I promise you. We did a lot of work on this. We did a lot of work to make this simple to do. So you can do this. I'd also like to talk about app service lifetime. Now, app services are launched by client apps. So in our minds, we think of them as something that is sponsored by the client app. The reason we think of it that way is because this is a device with a battery that is going to run out. And we don't want it to run out any faster than it usually will. So as soon as the client goes away, we will terminate any app services it might have launched. But as long as the client is around, the user is using it, your app service will run. Now, if you're launching a whole bunch of app services concurrently, if you're launching like 5 or 6 different app services from 5 or 6 apps, you also need to think about the amount of memory each of those app services uses up. And we'll tell you, if you try to launch an app service and we have no memory for you, we'll come back to you and say, no, can't launch that one. And we'll tell you, resource limit exceeded or something like that, which will tell you that, oh, OK, there's not enough resources here. And those resources almost always mean memory, because we've got quad-core processors now, and CPUs aren't a big problem. OK, let's wrap up. There's some best practices that you should keep in mind, and that's why this is in the wrap-up section. We don't want to impose anything on you, but these are good guidelines, which we've observed sometimes on other platforms, sometimes from the way people have been doing things internally. When you want other people to deep link into your app or call app services in your app, it's a good idea to wrap all that code that opens the app service connection and sends messages and receives messages, or code that launches an app for results. It's a good idea to wrap all that code in an SDK, which could just be a DLL that you hand other people. Or you could use NuGet. Anybody who uses Visual Studio has NuGet already. It's a package management feature that's part of Visual Studio, although you can also use it separately, which lets people get a hold of packages like these SDKs. So that's a great way to distribute them. It also gives you some notion of control over the kind of code people are using to access your app services and your custom schemes. Lastly, versioning. Versioning is always one of those things that nobody thinks about when you start a project, because you're all like, yeah, it's going to have all the features, all of them. And then days go by, you release your first version, and somebody says, oh, does it have that feature? And you're like, oh, got to add that. Or why doesn't that feature work that way? Oh, breaking change. So if you're making a breaking change, do a new version of your app service or custom scheme. If you're making a non-breaking change, just add it on, because you're not actually exchanging any real types. You're just exchanging value sets. So it's very JSON-like. It's very, very REST-like. So a recap. We talked about the launcher enhancements, the deep linking enhancements. You can launch a specific app. You can send over files. you can launch other apps for results. We also talked about app services, where apps can provide services to other apps, and of course, all apps can consume those services. Who's using these APIs? If you've been attending some of the Cortana integration sessions, how does your app sign up to be called from Cortana and all that, they've been using our APIs. The Photos app, the Cameras app, the Camera app that ship inside of Windows have been using our APIs. The Interactive Toast folks have been using custom schemes to drive interactivity. And of course, we're really, really hoping that all of you will use our APIs and give us feedback about what's great, what's not so great, and what we can do to come back next year and have some more stuff to show you. These are some sessions that are related or talk about similar things. They've all happened by now, because this is the last session on the last day, so don't go out and look for them, please. Go home, boot up Channel 9. If you've got an Xbox One, there's an app on here, on there, and use that to watch all those sessions. This is the team. I stand up here and talk about all this stuff, yet I am a very, very small part of the set of people who actually did anything to make this come to life. So these are the people who contributed code, samples, documentation, lots of other stuff to make all this code come to life. That's it. Please give us feedback, and thank you for coming. Oh, and I'll take questions, but I'm going to be in the Insider Lounge after 3. So if you've got more questions than I can answer here, please come over. Use the mics if you want to, because that way the questions get recorded for folks watching this on video.
Launch an app for results. Does the second app close down as soon as it returns back its results?
Yes. Yes,
Okay.
it is.
So the question I have, first of all, I'd like to say thank you for adding IPC mechanisms to WinRT. That's great.
Yes.
Now, the question I have is, so you have an app that provides a service.
Mm-hmm.
In some cases, like the one you showed, that app doesn't really need to have any UI at all. And so it doesn't really need to be an app. It can be just a service. So do you have anything of that sort, or do we really have to have an app that doesn't do anything, just has a blank screen like you showed, just to provide a service to another app that can use it?
So yeah, we kind of have a name for that scenario. It's kind of an unfortunate name because we call them headless apps. But yeah, that's the scenario we've got. Somebody is working on it. I am not sure whether it made Windows 10, but somebody is working on it. So if it's not shown up already, it'll show up in one of the subsequent flights. So why don't you send me an email or tweet at me, and I'll make sure I connect you to whoever's working on that.
Okay, thanks. And
It's available for IoT. I just talked to someone about
So it is available?
for IoT.
Oh, for
Just
IoT.
For IoT, and there's
Okay, I see. So I'm not sure whether it's available for mobile or desktop, but I will find out.
okay, and is there any way to communicate not just between apps, but also between apps and, say, Win32 apps or services?
So I don't know whether you saw Kevin Gallo's keynote on day 2, but he showed off a WPF app that actually talked to an app service in a modern app. So yes, that is possible.
Okay. Yeah.
I plan to blog about that. I didn't talk about it, but I plan to blog about it.
Okay. Thanks.
Can you talk about the performance of this IPC mechanism?
Sure. App services or launching for results?
Basically, I'm just curious what kind of latency should we
Okay.
think about it? Is this like
So-
RPC, speed, or what's going on here?
So the launch APIs are literally launching another app. So it's going to have whatever cost there is for launching an app.
Sure.
So that's established cost, and it's not going to go up or down. App services under the covers are actually named pipes.
Okay, name pipes.
So they're pretty fast. We've got good numbers on that, and our goal was to at least, and I know this is a low bar, at least be faster than talking to a web service. But we've achieved much better than that. So we've achieved much better than that, and I'm grateful for that. But we're talking tens of milliseconds, possibly. But a lot also depends on the sort of device you've got. But the latency is quite good. The other thing we do, because we really care about performance, is once we brokered the connection, once the connection's been established, we get out of the way. So when you're sending data to another app, you're literally sending data over a name pipe to another process. We're not standing in the way, and that's very deliberate because we want it to be fast.
Fantastic, thank you.
All right, for a website, if you have an enhanced experience on your app and the person visits that website through another link, you want to launch the app automatically, and you can't use custom protocols because you need to fall back to HTTP. So can you register for HTTP and filter on the domain?
Let me just say, not yet, but that's on the list.
Because
I'm thinking about it.
that's what Android does with.
I know Android has that feature, and I'm well aware of it. Because I care about this stuff, it's definitely on our list of things to go do.
So, is there a limit on the size of the results that an app can return?
There's no limit on the size of the value set that you can send around when you're using app services. But
Okay.
when launching for results, the value set has a 100 kilobyte limit.
Okay.
But that limit does not apply to any files you might be sending across. So if you've got a giant amount of data, it's probably more efficient to just stick it in a file and send a file token back.
Okay, I have a couple more questions. The question is, when you send files through a file token, through the protocol URI, in that case, how long is the token valid?
It's a short period of time.
Okay, is there a documentation for that?
There's going to be. We're still debating how short that period of time needs to be. Because the main reason being, there's a couple of things here. It's a one-time use token. Once you've redeemed it, it's useless.
Okay.
And the second thing is, we don't want that token sitting around for very long.
Okay.
And if you want to hold on to the file, you can. Once you've redeemed the storage file, you can put it in an access list, and it can stay there pretty much forever.
Okay.
So the token lifetime shouldn't be a problem. The exact token lifetime, we'll get that documented as soon as we decide.
Okay. So the last question I had was regarding the package family name. So if I write an app that I publish to store, I also give it to enterprises where they can sign the app and install the app.
Sure.
The name would be different in both the scenarios?
Yes, because it depends on how they sign it. If they're signing it with a different certificate, the package family name is going to be different.
So in that case, how can we write a web of apps if the package family name is going to be different in different scenarios? Like, for enterprises, we will not be able to code correctly.
Well, no, you can still detect. There's the query APIs that you can use to detect which version of your app is installed. All that's happened here is now there are two different parallel versions of your app. But you can code around that quite easily. You can say, query for my first package family name and then query for the second one.
Yeah, but the question is, say if app A and app B want to communicate, and when it wants to communicate to app B, doesn't know the family name of app B. And how would it know? App B can find its family name by the API, whatever is available. So how can app B tell app A that this is my family name, use this to communicate to me?
Well, the assumption here is that app B gave its family name to app A sometime in the past. That app A already knows the family name.
Okay.
Right? It's an identifier. Right? You give me your name, and that's how I know how to reach you. But
Yeah.
I can't reach you if I don't know your name.
Okay.
It's kind of the idea.
Thank you.
So what about streaming large amounts of binary data between apps or sharing memory between apps?
If you can split it up into value sets, you can stream it. But you can't just send a stream handle across.
Okay. So specifically like Project C, taking a bunch of data that you're using in memory, like in a C++ Win32 app,
Right.
and shooting it across to a universal app for display purposes. So if there's a lot of data going across, like say
Oh,
financial
sure.
graphing and stuff,
Stick it in a giant byte buffer and just
shoot
push
it right over.
across. Yeah.
Okay, cool.
It would create a copy of that memory in the other app, of course.
Okay,
You're not sharing memory at any point in time.
okay.
So I had a question about packaging up the app services components. So I actually looked at your demo code a little bit since you put it up on GitHub. And so the output of the app services project is a .winmd file. I believe that's what I saw.
Yes,
So-
yes, I think it is. Yes.
So, and then the solution you have, everything is just all-in-one solution for simplicity. But if you were actually going to take that component and distribute it to different, to at least a different mobile app that was outside the solution, is the .winmd file how you would reference it? Because I'm wondering how the Universal app knows about the component when it's launching it.
.winmd file is just it's a bunch of Windows metadata alongside a binary.
Right.
Sorry.
So I was working with brokered components previously, and the brokered component had like a file reference to the .winmd file. So I noticed in the demo project, it doesn't have the main app that it's associated with, the Universal app doesn't have a reference to the app services component
Oh, it
in
does.
it.
It does.
Under the Visual Studio references? Okay, I must have missed
You
it.
mean the caller of the app service, or do you mean Fabricam shiptrack the provider?
I mean Fabricam ship, like the one that's
it
hosting
did,
it.
it
basically.
did have a reference to the WinMD.
Okay, I must have just not seen it.
Don't
Okay,
worry about it. No, it's not magic.
yeah,
Still not magic.
that's kind of what I was wondering. All right, thanks.
Okay, so say you have app A that launches app B, and it's waiting for a result, and then app B launches app C, which is also waiting for a result, and then somehow the user terminates app B. What would happen?
The user can't access app B because when app A launches app B, they can't, like in the UI, they can't get to app A because app B comes up modally on top of app A. And the same also applies to when app B launches app C.
What happens if they open up a task manager or some third-party application that would close it? Or what happens if app C,
Or it just crashes.
Or it just crashes.
yeah,
that's-
or app C closes app B somehow, or some funky scenario
so
like that?
Crashes in target apps show up in the source apps as cancellations. So you get a result back, but the result is null.
Okay, and then what about the scenario where the initial app A, is the one that would have this
Everything
issue?
gets torn down.
Everything else just goes away?
Yeah.
Because the connections will
'Cause
be
we gotta
closed,
clean up.
so it'll automatically
Yeah,
terminate
okay.
the
Yeah, I'm just-
service.
It's a shell game.
Okay.
So my question has to do with store certification of apps that contain or, either are only about app services or primarily about them. So whether it's headless or it's got a blank white screen because we can't do headless yet. There's an awful lot of code in there that isn't going to be exercisable by anyone reviewing that app. So what is the thinking about requirements for submitting test harness or a second app that exercises the app services-based APIs or anything along those lines?
And I bet that's what, I personally am not looking at the headless apps problem, but I bet that's what the people who are looking at are debating about. But I'm gonna find who it is and take this feedback back to
Okay.
them. It's
Yeah.
just, Microsoft's kind of a big company.
Yeah, no, I work for Microsoft, so I get it,
So
yeah.
I've heard of this. I've heard somebody's going.
I don't know who to talk to either, which is why I'm here.
I think I know the team, so I'll
Okay.
go talk to them. In
Yep.
fact, Jason's probably on that team. He's right there. I'm going to talk to him.
Perfect. Thanks.
Okay, so let's say you have an app services app that is also a foreground app. So it executes in the foreground and then at some point gets suspended. So it's still in memory but suspended.
Okay.
And then a client app calls the service. Would that service get executed in the process that was previously suspended, or would it be a separate background task process that will handle the request? And the reason I'm asking is about state sharing between potentially a new background task process versus the original suspended process.
So here's the thing. So normally, when you provide a background task, and this applies to other sorts of background tasks as well, it actually executes in a host process called background task host.exe, which has nothing to do with your foreground.
Sure.
It's the same app container, so it has access to the same things, but it's a separate process. So if you've got one of those setups, the app service just runs. It runs inside of background task host.exe. Now, we've introduced this model wherein now you can host a background task within your foreground app, and I encourage you to go watch the background task session that Sean Henry did a couple of days ago. And with that, what you can do is you can have the background task run in your foreground executable.
Okay.
In that case, what will happen is even if the executable itself is suspended, the UI thread is frozen, it's not getting any CPU, we will start another thread within that process, and it'll get CPU and it'll be able to do things. But the moment it calls into the UI thread, things just grind to a halt.
Okay, so the UI threads are still not active, but there will be separate threads, but within the same process.
Yes.
Okay, that's
so
great.
So that's possible. And the exact details of how to host a background task in process, that's in his talk.
Yeah, that's great. That's exactly what I needed. Yeah, thank you.
Are there any additional concerns about security? Are there needs to endpoint? Are there ways that man-in-the-middle attacks can happen? I mean,
We're not very concerned about man-in-the-middle attacks. What we are, the big security concern, because like I said, it's literally a name pipe between two apps, and we set up and we broker the setup of the name pipe, so somebody you trust is doing it, and we use strong identities on both sides to broker that name pipe. So man-in-the-middle, I wouldn't worry about so much. What I would worry about, and this is more something that we've thought about from a perspective of users, is I'm an app, I'm calling an app service in another app which has capabilities that I don't have. Maybe it can tell the location of the user and I can't. And that's something we're going to be looking very closely at. At the moment, there are no restrictions, but that's something we do. That's something that worries me. Let me put it that way. And we've got a lot of telemetry around that, and we're going to be watching it.